Welcome to the exciting world of software testing. Landing your dream testing job requires more than just technical skills. You need to impress potential employers with your knowledge and passion. This journey begins with thorough interview preparation. Think of the interview as a grand expedition. You are the explorer, and the interviewer wants to know if you have the skills and knowledge to navigate the challenging terrain of software development. Preparation is your compass and map, guiding you towards success. Just like an explorer studies maps and packs essential gear, you should research common interview questions and practice your answers. This preparation will boost your confidence and help you stand out from the crowd. Remember, a well-prepared explorer is more likely to discover hidden treasures. So, are you ready to embark on this exciting journey? Let's dive into the essential concepts you'll need to conquer your testing interview. Before venturing into the wild world of testing interviews, it's crucial to understand the fundamental concepts. These concepts form the backbone of your testing knowledge and will be the foundation upon which many interview questions are based. Without a solid grasp of these basics, you might find yourself struggling to answer even the simplest of questions. Think of these concepts as the building blocks of your testing knowledge. Just as a house needs a strong foundation to stand tall, your understanding of testing fundamentals will support your ability to tackle more complex topics. These building blocks will not only help you in interviews, but also in your day-to-day testing activities. One key concept to grasp is the difference between defect severity and defect priority. These terms are often used interchangeably, but they have distinct meanings and implications in the world of software testing. Severity refers to the impact of a defect on the software's functionality. It measures how much a defect can affect the system's operation. For instance, a high-severity defect can cause the application to crash, rendering it unusable for the end users. On the other hand, a low-severity defect might just be a minor visual flaw that doesn't significantly impact the user's experience. Understanding the severity of a defect helps prioritize which issues need immediate attention and which can be addressed later. Priority, on the other hand, determines the urgency of fixing a defect. It is a measure of how soon a defect should be resolved. A high-priority defect needs immediate attention because it affects critical functionality or a large number of users. Conversely, a low-priority defect might be something that can be fixed in a future release or when time permits. Balancing severity and priority is crucial for effective defect management and ensuring that the most critical issues are addressed promptly. Another important distinction to understand is between functional and non-functional testing. These two types of testing serve different purposes and focus on different aspects of the software. Functional testing ensures that the software behaves as expected, focusing on its features and functionalities. It involves verifying that the software performs its intended tasks correctly and meets the specified requirements. Non-functional testing, however, assesses aspects like performance, security, and usability. Imagine testing a car. Functional testing ensures the car starts, accelerates, and brakes as it should. Non-functional testing, on the other hand, checks its fuel efficiency, safety features, and how comfortable it is to drive. These tests ensure that the car not only functions correctly, but also provides a good user experience. For example, non-functional testing would involve assessing how the car performs in a crash test, its fuel efficiency under different conditions, and the comfort level for the driver and passengers. These aspects are crucial for the overall quality and user satisfaction of the product. Finally, you should be familiar with ad hoc testing. This informal testing approach doesn't follow a structured plan and relies on the tester's intuition and experience to uncover defects. It's a flexible and spontaneous way to find issues that might not be caught through formal testing methods. Ad hoc testing is like exploring a new city without a map. You might stumble upon hidden gems, but you might also get lost. This method allows testers to think outside the box and discover unexpected issues that structured testing might miss. It's an excellent way to complement formal testing techniques and ensure a more thorough examination of the software. By combining structured and ad hoc testing, you can achieve a more comprehensive understanding of the software's quality. Understanding these fundamental concepts will equip you with the basic knowledge needed to tackle more complex interview questions. It will also enhance your ability to perform effective testing in real-world scenarios. Let's explore some key testing concepts that will further solidify your understanding. By delving deeper into these topics, you'll be better prepared for interviews and more capable of contributing to your team's testing efforts. As you delve deeper into the world of testing, you'll encounter specific concepts that are crucial for success. These concepts form the backbone of effective testing practices and are essential for ensuring the quality and reliability of software products. These concepts provide a framework for designing and executing effective tests. They help testers understand the scope of their work, identify potential issues early, and ensure that the software meets its requirements. A test harness is a collection of software and test data configured to test a program unit by controlling its input and monitoring its output. It acts as a controlled environment where testers can simulate various conditions and observe how the software behaves. Imagine it as a customized laboratory setting for your software, where you can control the variables and observe the results. This allows for precise and repeatable testing, which is crucial for identifying and fixing bugs. Boundary value analysis is a technique that focuses on testing the edges of input values. This method is based on the idea that errors are more likely to occur at the boundaries of input ranges. For example, if a field accepts numbers between 1 and 100, you would test what happens when you enter 0, 1, 100, and 101. By doing so, you can identify any issues that occur at the limits of acceptable input. This helps identify errors at the boundaries of acceptable input ranges. It ensures that the software can handle edge cases gracefully and without failure. Equivalence partitioning, on the other hand, involves dividing input data into groups that are expected to be treated similarly by the software. This technique reduces the number of test cases needed while still providing thorough coverage. Instead of testing every single value, you select representative values from each partition. This approach ensures that you test a wide range of scenarios without the need for exhaustive testing. This approach optimizes testing efforts while ensuring adequate coverage. It allows testers to focus on the most critical areas and identify potential issues more efficiently. Understanding these concepts will demonstrate your ability to think critically about testing and design effective test cases. It shows that you can apply systematic methods to ensure the software meets its requirements and performs reliably. Now let's move on to the actual execution of tests and different testing strategies. By applying these key concepts, you'll be well equipped to tackle the challenges of software testing and contribute to the development of high-quality software products. Having explored the essential concepts, let's now focus on the practical aspects of test execution and different strategies employed in software testing. This is where theory meets practice, and we see how all the planning and preparation come to life in real-world scenarios. Entry and exit criteria are predefined conditions that determine when a testing phase can begin, entry criteria, and when it is considered complete, exit criteria. These criteria act as gatekeepers, ensuring that each phase of testing is only initiated or concluded when specific conditions are met, thereby maintaining the integrity and quality of the testing process. It's like having checkpoints on your expedition, ensuring you've gathered enough resources before setting off and that you've achieved your goals before moving to the next stage. These checkpoints help in tracking progress and ensuring that no critical steps are missed, much like a hiker ensuring they have the necessary supplies before continuing their journey. End-to-end testing involves testing the entire software product from start to finish, simulating real user scenarios. This type of testing ensures that all integrated components of the application function as expected in a real-world environment, providing a comprehensive assessment of the system's performance. Imagine testing a food delivery app. This involves not just the user interface, but also the back-end processes, ensuring that every step of the user journey is seamless and error-free. You would test the entire process from the user placing an order to the restaurant receiving it, the delivery driver picking it up, and finally the user receiving their food. Each step must be verified to ensure that the system handles all interactions correctly and efficiently. Negative testing focuses on what the software should not do. This type of testing is crucial for identifying potential vulnerabilities and ensuring that the system can handle unexpected or incorrect inputs gracefully. Instead of providing valid input, you intentionally input invalid data or perform unexpected actions to see how the system responds. This helps in identifying weaknesses and ensuring that the software can handle errors without crashing or producing incorrect results. It's like testing the durability of a bridge by subjecting it to extreme loads and conditions. Just as engineers test the limits of a bridge to ensure its safety and reliability, negative testing pushes the software to its limits to ensure it can withstand real-world challenges. Understanding these practical aspects of testing will showcase your ability to apply your knowledge in real-world scenarios. This hands-on experience is invaluable as it demonstrates your capability to not only understand theoretical concepts but also implement them effectively in practice. Next, let's clarify the distinction between two commonly confused terms: regression testing and retesting. Regression testing ensures that new code changes do not adversely affect the existing functionality of the software, while retesting involves verifying that specific defects have been fixed. Both are essential for maintaining the quality and reliability of the software, but they serve different purposes in the testing process.